So what is VIP monitoring and what are these demarcation features? It's basically where we set up a rapid automated scan of VIP customer premises, and we are going to monitor those circuits with the remote fiber test system. So that's a totally automated, hands-off process. It will create an automatically alarm, and then reporting can demarcate between the sections of the network. PON architecture is cascaded. So in other words, we have a splitter followed by another splitter, and we need to determine what section of the network the fault is in. And by doing that, we can also typically determine how many customers are being affected. And I can show you that on the picture in a minute. So in this case, the field tech, a NOC engineer, or a service rep can utilize the system. They can, at any time, anywhere, they can have an automatic alarm sent to them from the VIP monitoring feature, or they can just instantly access it from a PC or a mobile device and perform a test on demand if they suspect some sort of a problem. So why do we care? We want to prioritize those VIPs, and who might they be? Very large business customers or small business customers. You may have cell sites that require front haul, back haul services. And then we could just have smaller homes that, have an important need for critical service, or we could have a hospital or a school, some other type of customer like that, where it's absolutely critical that they're up and running all the time. We want to accelerate the troubleshooting process by 75% and improve productivity of our staff, get actionable reporting, and be able to track what our mean time to resolution is and what locations in the network are getting damaged or broken. And then we want to meet the SLAs that we have with those VIP customers so that we can provide them with great uptime, really good service reliability, and give them reporting on it. So here's an example, and this represents the demo architecture that we'll be showing you today. We have a racked fiber test head on the left-hand side in our central office. Then we have the feeder cable. So that feeder cable, of course, is affecting everybody downstream. Then we have our first splitter with a 1x4 splitter, and we go into the distribution section of the network. And from this point on, we'll have another splitter, and then we'll break down with a 1x8 section of fibers there and all of our VIP premises. And so those VIP premises, as I mentioned before, it could be some sort of radio area network, could be a home, could be a business. But what we need to have is a reflector at every VIP premise so that we can amplify the signal, the reflectance, so that we can see if that particular VIP ends up being disturbed for any reason. And so this is a typical PON architecture, and the system has been designed to accommodate it. So we want to know, where is the break, right? So it's designed to always alarm and locate a break in the feeder cable. And the reason for that, of course, is that everybody downstream here is affected when our feeder has a break. It's very critical that our feeder is always up and running. We want to know of an issue right away. We can always alarm and locate if it's a complete break in the distribution section of the network. And it needs to be a single cable that's going to one place in order to locate a problem in that. So we might see that there's a problem, but not be able to actually locate the precise optical distance. And we want to make sure that we can. So we only do that for a complete break in order to avoid false alarms. And then if it's not in either of these sections, in the feeder or the distribution, we'll be able to tell you that you've got a problem in your drop cable to the VIP premise. And so you can see how this is really helpful in order to be able to ensure that you dispatch to fix the right location and can avoid unnecessary fiber handling and unnecessary trip rolls, right? So, and it is often possible in a PON network. We have our passive network, which we're looking at here, and we also have our active. So those are going to be our lasers that are sitting here in the central office in the OLT, and then we'll have our ONT over here at the premise. And those active network equipment elements can also have a fault, right? So we want to demarcate between the fiber and the elements as well, and this helps us do that. So what is the process for conducting this VIP monitoring and demarcation. How do we initiate it and how do we use it? So number one, we have to have a reflector at the premise location, as I mentioned. So that's step number one. We have to have that there. Number two, we have to either import or select existing network inventory and the premise locations that are associated with the ONTs so that we can ensure that we can see that particular location and start to track it. So that's going to be identified by a port. And we can either collect that in the database as we're building out the network, or we can add it later if we've already built our network. Then we're going to assign premises as VIP status to trigger an auto calibration by the fiber test head. And it will also add it to a monitoring routine. And we can use that for up to 50 VIP customers per optical test head or optical test unit. And our optical test units scale up to over 4,000 ports. So you can effectively use it by having a section dedicated to monitoring, and then we can still do activation testing on demand with the remaining fiber ports that are on the test head, or construction testing, so that we have multiple uses, because we know that we don't build our network all at one time. People subscribe, unsubscribe. So we need to have capacity for all three phases of the life cycle at any given time. Then the fourth step will be to see an alarm, right? And look at our demarcation reporting. And then finally, we'll dispatch to fix, recertify with our mobile app. And once we've repaired it and clear the alarm, make sure that our network is back working and we've got reporting to analyze after that, okay? So we're gonna meet our SLAs and we're gonna have radically improved uptime. So the goal here is on the right to save up to 50% or 75% of our troubleshooting time and ultimately reduce our OpEx so that we're not dispatching people, spending hours trying to find the problem. Instead, we're going to know the problem's there, find it remotely, and we're going to increase that efficiency, profitability, and customer satisfaction, because ultimately our VIP customers are going to experience much more security, better uptime, and less disruption to their business. Okay, so let's start the demo portion of our discussion for the ONMSi VIP monitoring. So ONMSi will allow you to import inventory that you are either planning to build or that you have built. And so that's what this menu is over here. We can download templates, we can create download central offices, PONs, homes, and PON test points. Normally you would import all of your plan, then you would build and test as you build against that plan so that you could select, for example, a particular section of the feeder with test points, test against it, and accept those test points as passing the OTDR traces. And then you would go ahead and record those in the database and store them. In this example, we're going to show you how to import the list of new subscribers that you want to select from as your VIPs. And so that's what we're going to do here with this Excel spreadsheet. So now you can see we've got a list of home names, home identifiers. We could add a description, for example, people's names. We have PON, the PON external ID that it is located on. We have the option to make this true under the VIP category, and we could say true and then just make them a VIP. But we'll also show you how to do that through the software. And then we have the termination type, which I will talk about in a little minute. Okay, so now that we've imported that, let's go to our PON. All right, so now we're going to go to the optical switch number 2, the second line, and look at PON UHR 2-6. So let's go ahead and click on that. And you can see that this one has already been calibrated. So what that means is we've got a reference baseline peak trace in there. And so when we go to calibrate against that baseline, we'll be able to determine that it is the right one and then establish or declare that as a VIP in the software. There's the calibration mark. So it's ready to go. So let's click on Edit. Okay, we selected the PON, and now we're going to start the test. Now it's doing an on-demand OTDR trace, an on-demand test, and this is part of our calibration process. So it's going to come up with a list of all of those PON locations that are on this particular port and PON section. And so imagine if you had a 1x8 splitter, you would see 8 homes behind that area, and you would select the subscriber that you want to make a VIP. So we're going to click the one that we are wanting to make a VIP, and Sylvain knows exactly which one is at the right distance because he's got his demo set up correctly. So he's going to select it, edit it, and add PON UHR subscriber 2-6. And then the next thing we need to do is select our reflector type. In our demo structure, we have 2 different types of reflectors, and that's important to establish the right reflectance characteristics. Okay, so let's go ahead and look at our options here. As I mentioned, the termination type is important. So when you are building your network and you have just built out your distribution section to a particular residential area, all the homes in that area are now considered passed. When we add the drop line from the distribution down to the actual home, that means it's been terminated and it's ready to be tested for service activation. And finally, when we actually connect service and they have live fiber traffic, they are connected. And so in order to make someone a VIP, we need to make sure that we actually have a subscriber there, and we want to select them as a connected subscriber. So now that we've done that, we're going to check the box for VIP and declare them a VIP monitoring candidate. Now you'll note that up here, it says that we will schedule as often as possible. We're going to save that, and that's going to set the system up to start monitoring that location 24/7. So let's go look at our optical test head and see if it's acquiring, and it is. So we have the acquisition in process, and it will continue to constantly scan all the fibers that are included in the VIP schedule and constantly make sure that they are not disrupted. So right now, we just have UHR 2-7. So our scan is happening over and over and over at one location. Now we're going to simulate a break, which will generate an alarm at our VIP location. All right, now we have the alarm. So you see the severity is critical, and it is UHR 2-6 that has the alarm. Missing peak, which means that there's a missing OTDR peak, and that is a critical alarm. There's PON UHR 2-6, and it says that it's down, meaning that it has lost all of its optical signal. Now, if we want to go see more information about this alarm, we'll click over here and we can get more data on it. And so we'll see how many different VIPs have been affected by this alarm. So for example, let's just say we had our feeder affected. All of our VIPs behind the feeder would show up in this list. Since we've only established one VIP, that's all we will see in this simple test that we want to use to demonstrate how it works. But as you can see, we now know that we have our VIP out of service, and we need to make sure that we fix their problem as soon as possible. So when this alarm occurs, now we can have the alarm notification go to several different people. So the operations team can be notified, for example, to go out and fix the problem. The NOC team can be notified, and the customer service team could be notified. So the service team could call that particular VIP and notify them that their network is down, that we are aware of the problem and we are working on it, that we can see where the break has happened, so that they can fail over. Let's just say they were a data center customer or had some sort of critical process. They might be able to fail over to a redundant line or take some other action while we repair their network. So at least we have been able to meet our SLA, notify them as soon as we find the break, and notify them how long it might take us to repair the problem. Thanks for watching.